Hey, this is problem number 3 of the op-amp, the adjustable gain problem. So the goal was to insert a potentiometer into an op-amp configuration to make it go from 10 decibels to 40 decibels, which is a 3.162 volts per volt gain to a 100 volts per volt gain. So we decided to use a 1K potentiometer, and then so that means that you need to get X being this number right here, this resistor. You need to get 1,000 ohms plus 3.162 times X over X to equal 100. So that's what your new gain is going to be. And then so then we calculate that out, and we get X to be basically 10 ohms. And this works out really well because the potentiometer, when it's down to 0, has a resistance of about 0.18 ohms. So we can just put the potentiometer in series with 30 ohms, and we should be about right. And so there's the configuration. And here it is in real life. And then here's what we got on the screen. As you can see, we have this is when it's high. We have different volts per division for each input. So this is the original input, and its peak-to-peak voltage is 200 millivolts, which is what we wanted as specified. And then the output is 20.47 volts, which is 100 times that, which would be 40 decibels, would be 20 volts. So that's pretty close. It's basically what we want, and that's when the potentiometer is high. Now we're going to move the potentiometer using this guy. So we move the potentiometer down. And then, oh, okay. There you go. So I moved it all the way down, so now it looks bad. So let's get the volts per division equal. So now we got the same volts per division. And as you can see, we have 200 millivolts as our input again. And now we've got 593 millivolts as our output, with the potentiometer turned all the way down. So that's basically a 3 volt per volt gain, which is close to our 10 decibels. So we went from a 3 volt per volt gain to a 100 volt per volt gain just by moving the potentiometer. So that is problem number 3.